Okay guys, we are going to learn piecewise functions, the graph of the piecewise functions today, same way as we did the evaluating piecewise functions yesterday. Today we are going to look at the domain and see how do we graph these functions within the given domain. So if you see, this graph is x less than equal to 0 here, it's between x is between 0 and 3 here, and this is x greater than equal to 3 here, and that's where we are graphing. And each of these domain has three different equations attached to it. So less than equal to and greater than equal to, as we know from the past, is a closed circle, and greater than and less than is a open circle. So for greater than, less than, we used an open circle while we are graphing. So the first thing we are going to do here is to draw our boundary lines at 0 and 3, because those are the two things where we have a boundary, and that's where the graph is going. So I draw a line on top of 0, and then I draw a line on top of x equals 3. So what these lines will represent, these are the boundaries of our function. Like we can take on the left side of 0, we can take the function in between 0 and 3, and then we can take a function greater than 3. So if I am going x less than equal to 0, we take the first function, because that's where our domain is working. It's x less than equal to 0, our function is x minus 1. So if we take our function x minus 1, what kind of function is this? This is a linear function, and whenever there is a linear function, that means it is in a form y equals mx plus b, which you should already know by now that it has a y-intercept and then it has a slope. So our y-intercept here is -1 and our slope is 1 over 1. So we go at x equals 0, which is this line. So at 0 the value is -1, and because it's less than equal to 0, we are taking a closed circle here at -1, and now the slope is 1 over 1. So we can either go up 1 over 1, but we cannot go past on the right hand side of this boundary line. So we have to go on the left hand side, which means we go down 1, left 1, down 1, left 1. We go keep going down, and this is all the graph we need for right now, because we cannot go past 0 because our domain stops at 0. Now from 0 to 3 we are following the next function, which is -x plus 1. Again, on the next function our y-intercept is b equals 1 and our slope is -1 over 1. So I get b equals 1, and I have an open circle this time, because at 0 this has x is greater than 0, but it has an open circle because no equal to sign here. So it goes at 0, and now instead of going up and right, we are going down and right, because it's a negative slope. It has a -1 over 1. So I go down 1 over 1, down 1 over 1, and at 3 it again has a open circle, and we stop there. Now after 3x greater than equal to 3, the value of the function is same all over. So at 3 it takes the value of 3, and it's a closed circle because of this greater than equal to 3, and greater than equal to 3, the value of the function is always 3. So we go ahead and draw the value of the function, which is always 3, and after that you can erase your boundary lines, because boundary lines otherwise will represent the function which you don't need there. So you have to go ahead and erase all your boundary lines and see the function as it is right now, and then we can write the domain and range of this function. And what is the domain and range of this function? The domain of the function, if you go from left, it starts from -infinity. You keep going. Over here there is closed and open circle, which means you put a lid on the open circle, which makes that value true, and then you keep going. So our domain is -infinity to infinity, but our range, if you go, is from -infinity. You keep going, but you stop at 1. So the range goes from -infinity to 1 with the open circle there, because it's not taking that y value. and then it starts back again at 3 and it remains at 3 after that. So it stays at 3 after that. Whereas now I go to the next question, our boundary line again. Our boundary line is at -3 and 3. So our boundary line is at -3 and at 3. And then you see the function value at less than equal to -3 is always 2. It's the equal to sign. So at 2 you take an open circle and it's always going to be a constant function 2. Between -3 and 3 it's taking a value of -1, and at -1 actually it has an open circle at -1 and it says -1 to 1 from -3 to 3 because it's a constant value again, and then again it's a constant value of 3 for anything above 3, but it starts with the open circle at 3 because of this equal to sign again here along with the greater than. So this is our final function that we will draw, and then we write the domain and range. And as I said, erase your lines because these will mean a x equals function 2 and we do not want those boundary lines there. So if you see a domain of the function, it starts from left to right and it's taking all the values from -infinity to infinity. But if you go to the range, it starts from -1, but it's not taking anything above anything other than -1. Then it takes a value of 2 and that's it, and then it takes a value of 3 and that's it. So it's taking the individual values, but it's not taking all -1, 2 and 3, does it? And then we go to question number 3, same thing, we draw the boundaries. Our boundaries are 0 and 2, so I draw a line at 0 and then I draw a line at 2, and the function less than equal to 0 is x plus 3. So if I plug in 0 into that x plus 3, at 0 plus 3 is 3. So at 0 the function value is 3, and then the slope is 1 over 1, but you are taking a positive slope, so you are going down 1, right 1, again down 1, right 1, down 1, right 1, down 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, and down 1, left 1. So you're taking a positive slope or down and left or up or right. Then from 0 to 2, it's a constant value 3. So you go at 3, from 0 to 2 it's 3, but at 0 it's an open circle. But because there is already a closed circle there, we cannot change it, but it's a closed circle at 2. And then at 2 again the same thing happens. Anything greater than 2, it's already at x equals 2, there is already a closed circle because of the earlier equation, so we cannot open it since it's already closed there, and we cannot draw on top of closed circle the open circle. So we leave it like this, and then we plug in 2 into the equation. 2 times 2 minus 1 is 4. So the value it's taking at 2, it's 4, 1, 2, 3, 4. So at 4 it's an open circle right now, and then it goes up 2 over 1, up 2 over 1, up 2 over 1 from there, and that's your equation. So at 2 it's actually at 2 it's not 4, at 2 it's 3, which I calculate 4 minus 1 is 3, not 4, oh gosh. So it's at 3, so it's an open circle, and you go up 2 over 1, up 2 over 1, up 2 over 1, which is right here. So it's a continuous graph there. Then you do the next one, which is, you can say the domain and range for on the function on the number 3 is both negative infinity to infinity because they are no open circles, and it's like a linear function. Most of it's a linear, it's going up, so it's increasing, then constant, and then again increasing. Let's do this one. You have a boundary line at 0, and then you have a boundary line at 5, 1, 2, 3, 4, 5. And then if you see this, the first equation for less than equal to 0 is a quadratic equation, but the biggest value it can take is 0, so we plug in 0, and at 0 we get a negative 1, and then that's a closed circle, and then if I plug in negative 1 there, it's 0. At negative 1 it's 0, and if I plug in negative 2 there, negative 2 square is 4, 4 minus 1 is 3, so actually it's going up 1 over 1, up 3 over 1, so the next one will be up 5 over 1. It's a quadratic with a 1, 3, 5 slope, and that's how you draw it. And then from 0 to 5 it's taking the second equation, so if I plug in 0 in the second equation, it's again negative 1. At negative 1 it's an open circle, but it's already closed, so we cannot do anything, and from there you go up 2 over 1, up 2 over 1, because it's a linear equation, and you can keep going until it reaches the next boundary line, which is this one, and at next boundary line again it's a closed circle. Then at x greater than equal to 5, the value is the constant 3, so you go at 3, you keep an open circle because it's greater than, and then you draw a constant function there. And after drawing a constant function, you can erase your boundary lines there, and that's your final function. So your domain is again from left to right, it's moving all the way through, so it's negative infinity to infinity, and your range is starting from the minimum value of negative 1, and it keeps going all the way to infinity, so it's negative 1 to infinity. On question number 5, again we draw a boundary line, but this time the boundary line is only at 1, so it's on the left of 1 or the right of 1. On the left of 1 we use this equation, which is starts at 3 and go up 2 over 1, so you go on this y-intercept, or you can plug in 1 as the least value. So when I plug in 1, 2 times 1 plus 3 is 5, so at 1 it's 5, 1, 2, 3, 4, 5, at 5 it's a closed circle because of this equal to sign, and then you go up 2 over 1, up 2 over 1, and that's you go up 2 over 1, or you go down to left 1. Actually it's a positive slope, so you have to use a positive slope, which is right here. And then greater than 1, if you see, if you have plug in negative 1 plus 4, it's all, the value is 3. At 3 it's an open circle, and then it's going down 1 over 1, down 1 over 1 because of the negative slope. And that's it right here. So the domain of this function is again all real numbers, which is t is negative infinity to infinity, and the range of this function is, it starts at the highest value of this function is 5, but the lowest is negative infinity, so we always go from the lowest to the highest, which is negative infinity to 5. And now on the last question that I'm going to try with you before you do your work on your own is number 6. For number 6 we also have a boundary line, and the boundary line, we forgot to erase the boundary line on our question number 5, so go ahead and do that for yourself. And on number 6 we draw a boundary at negative 3 and 1, and then you have a function less than negative 3, between less than negative 3, between negative 3 and 1, and greater than 1. So for less than negative 3 we take the first equation, which starts, so if I plug in negative 3 into this equation, it's negative 2 times negative 3 plus 3, which is 6 plus 3, which is 9, which is a pretty high number. So at negative 3 it's 9, which is right here, and it's a closed circle. But then you have to go for a negative slope, which is you go up 2 over 1. You cannot go down because you cannot go past negative 3, so I can only go up this way. And then from negative 3 to 1 we are using a square root function. So if I plug a negative 3 into the square root function, at negative 3 it's 0. So at negative 3 is 0, which is the open circle. And then next point we can plug in is negative 1. But if I plug in after negative 3, we can plug in negative 2. Negative 2, square root of negative 2 plus 3 is 1, and square root of 1 is 1. So we can take a point there. Then next one I would not put negative 1 or 0 because it will not give me a perfect square root. Next one I would like to put here is 1. So if I plug in 1, square root of 1 plus 3 is 4, square root of 4, which is 2. So at 1 it's 2, which is our next value. So this function is going like this, and it's an open circle at 1 again, because this function has open circle at negative 3 and 1. Now beyond 1 it's taking a value of this function, which is the absolute value of 1 minus 3, which is negative 2. So at 1 it's negative 2, which is a closed circle. So at negative 2 it's a closed circle because of this equal to sign, and then it goes up 1 over 1 as a slope because it's the absolute value function. And you can keep making the slope here and keep going, and that's it for this function. And it's divided into 3 parts, and then you can go and erase the boundary line and leave the function as it is. So this is our entire function right here for the sixth one. And what is the domain and range? So if I write the domain for the sixth function, it goes all the way from the left to the right, which is negative infinity to infinity. And if I go to the range, the lowest range it starts from is negative 2. So it starts from negative 2 and it goes all the way to infinity. So that's your domain and range for question number 6. I think you can try doing the questions at the back, and the sheet will be due tomorrow. And make sure you write all the information that is needed. You draw your boundary lines and think about your domain before you do this worksheet.